Now we'll see what are the phases of DevOps in a loop. This loop is very famous in DevOps practices implementation. The first activity, it starts with planning. Number one, you can see, and next one is build, then continuous integration as per the Agile methodology, and there will be deployment, and there will be operations through operate activity, and again continuous feedback is there. This particular continuous feedback is there across the activities also, and total I can say 6 major phases or stages in DevOps loop, and we'll see in the next slide what are the activities by phase wise or stage wise in DevOps. If you see in planning, you can have collaborative vision and design also. Like you collaborate for a particular product vision and designing that particular features. And next one is backlog grooming and prioritization by product managers. So what is backlog grooming? You have a product backlog items, PBIs, as per the Agile concepts, where product owner collects the story points from the users, and those are going to be distributed to the sprint teams. And every time, for every iteration, the product managers or product owners, they are going to groom the teams for adopting that particular prioritized items, PBIs, from the product backlogs. And they are going to use in the sprint cycles. That is the activity here. And when you are working for the build phase, staging environments for development need to be identified. They are going to set up for that, and building infrastructure as a code that need to be planned by the build engineers, or I can say in modern systems like DevOps practices, when they have DevOps engineers are going to work on that. And collaborative coding need to happen among the developers during building stage. And third one is continuous integration stage. If you see, continuous integration of code is there. You have a, let us say you have 3 Java code files. Each of them might be having some 100 to 200 lines, each of them between 100 to 200, and one developer has done in the previous builds using file1.java, then another developer has used file2.java, file3.java. These D1, D2, D3 developers worked earlier. Now what happens? You can swap the developers. They will be able to take the same code and integrate their respective changes in the code, and update the version in the version control system, and that is going to be deployed it by adding the new files also. If required, a file 4, 5, 6, something like new files are required in the Java code, those also can be integrated in the code also, and that is going to be considered for builds also. And at the same time, when you are doing CI activity, continuous integration, automated testing is mandatory, as we have discussed one of the Agile practices also. And deploy, if you see stage 4, release dashboards for different builds. We have seen in the HUD diagram. We'll go back to the previous thing, and we'll see that one more time as a recollection. And if you see here, you have continuous integration is there, you have automated testing is there, you have automated infrastructure. All these things are repeating in the DevOps loop cycle. So we'll go back to that. Now if you see continuous integration, automated testing we have seen in the HUD diagram, and deployment, when you see release dashboards for different builds, we have seen the continuous visibility in the HUD diagram for DevOps practices purpose. That denotes the dashboards for different builds. That is showing visibility about the product, and everybody can monitor using the dashboards what is happening for each task or each team wise also. And making automated deployments, obviously that is one of the activities we are supposed to do through Agile concepts. And operate stage, when it comes application and server performance monitoring in production. Obviously the ops team are going to monitor that through some tools, how the incidents are happening, how the failures are happening, such kind of things. And communication among teams, like among teams there is a collaboration, there is a communication happening it. If you go back to the previous slides, we'll map to that. In this, communication is there, collaboration is there. Here also the same thing is happening it in tasks also, as a part of the DevOps practices. And incident and change and problem tracking, like incident tracking, change tracking, problems tracking are happening across the teams, like delivery teams and SDLC teams and ops teams also, development teams and ops teams also. And continuous feedback is part of that. We have seen that making better products through user feedback. So that's all. This particular continuous feedback is embedded in the loop itself, DevOps loop itself. It is a part and parcel of each task what they are delivering it. Once the task is delivered, other teams are going to give feedback, or stakeholders are going to give the feedback. That's all about the phases and their activities in DevOps loop according to the loop. Now we'll compare it with by linking Agile practices for DevOps. Initially, if you see the history of the Agile development, it started up to integrating like a component integration, and continuous integration is happening it. After that, releases are going to be deployed it, different releases are planned it in iterations, and continuous delivery is enhanced it. Continuously builds are getting delivered it. Once the Agile practices are embedded within the teams for collaboration work, then deployments are happening it continuous under continuous delivery. Then continuous deployments are major activities happening it, and DevOps practices are adapted by combining the ops team with the SDLC teams. So that's where about the linking Agile practices for DevOps, you can understand it in indirectly through this picture. And now we'll see an overview of DevOps processes and continuous delivery teams within teams. If you see, there is a development team. They are putting into the VCS, version control systems, artifact repository is there, and QA teams are working, and they are integrating the code. Build deployment is happened it through the build engineers. Nowadays you can say DevOps engineers, and performance testing is going to be executed by the integration teams, and staging environment is built it for testing purpose. Once the test cycles or test levels are completed it, then you can see in the release management process, it is deployed into the production. Now operation teams are working it. So total, if you see, the activities are given pipelined into the production deployment. Till production deployment, each teams are working for their tasks. Now if you see, I have pulled some of the tasks for different roles in DevOps, how the DevOps practices and typical activities in a delivery cycle can be there. We can see that we will understand the typical delivery cycle steps with roles for a sprint cycle. I have taken a single sprint cycle, not overall project delivery, which is one iteration I can say, and for that I have divided into different activities or tasks by numbering it. If you see number one, let us say the developers identified the sprint items from the PBIs, product backlog items, and they are selecting the items prioritized for sprint. They are developing the test driven development approach, and they are developing the code also after that through the TDD, and they are conducting code reviews, and if any issues are found, then they are going to modify the code, and later on once the code review is successful, then they are going for unit test environment preparation. Then they are going to execute the TDD test cases, test driven development approach test cases, and they are fixing if there are any issues found during the unit testing, and code modification will happen. Number 3 onwards, it will be repeating all the tasks. Then later on they'll go for integration testing, and once the fifth activity is done by them developers, then there is a sixth activity by DevOps engineers in the column. If you see, they are preparing the integration test environment on that build, IT build. Then they will build the integration test environment. After that, the test engineers are taking part to conduct the integration test, smoke test under activity number 8, and they are sharing the feedback. If there are issues found, then the feedback is going to the number 9 activity for the developers. Developers are considering the feedback and going back to their task number 3, modifying the code and repeating all the activities. That will go up to 8th task. Then when 10th activity comes for test engineers, successful smoke test execution happens, means then they're preparing the test summary. Otherwise the feedback is going to be given, and again 9th step onwards it is going to be repeated it. Then once it is successful test is done, 13 is their activity, pass the IT build to system testing if there are no issues found it. And 14th stage activity we see, conduct integration testing, like they're conducting sorry, this particular thing, if you see, you please read it as system test, smoke test, and they are sharing the feedback. Again 9th will restart it. And 15th activity, if you see, on successful smoke test, they are going to conduct the system test scenarios. Even once this 13th activity is passed it, you can see 14th activity parallelly they are preparing the system test build and deploying into the system test environment, DevOps engineers. Once that is done, then the 14th these guys are picking up and they are going to conduct the system test ST smoke test scenarios. And once ST is successful, they are going to pass on to the build to the UAT. The 19th activity, DevOps engineers are going to consider into UAT build and they are going to deploy it. Then 20, if you see, they are going to conduct the UAT smoke test. Basically these people need to consider the UAT. There is a mistake in that. And UAT smoke test, they are taking it and they are sharing the feedback. If any issues are found, then 9th onwards it will be repeating all these gamut of the activities. And 20, if you see, successful smoke test, after that they are executing the UAT scenarios and they are preparing the test summary. And if it is successful, they are going to go forward with pilot test production environment. Before that, 25th, if you see, the build engineers or the DevOps engineers, they are going to deploy the build in production environment. Once it is deployed, 26A is picked up by the users. They are going to do pilot test in production environment as per the AZURE concepts and the project phases. And 26B coordinating for pilot testing by the ops engineers. And if there are no issues found, they are approving the build to deploy into the start the issue live this one live production usage. Then 29, if you see, ops engineers, once the build is deployed into the production successfully hosted to the users business purpose, they are monitoring production issues from day one onwards. I can say from Monday onwards, they might have started the activities after weekend deployment. And if they have found the issues, they are going to share the feedback to the users and users are going to consider them. Then it is going to be considered into next sprint cycle along with the next sprint cycle items. This is the cyclic process. If you refer to DevOps cycle, the delivery cycle, typical activities can be considered it for different roles. Now we understood each role guys responsibility and their activities and tasks, also how the repeating activity is happening. It wherever repeating activities are happening, it is going to be automated in DevOps practices. That's where I would like to bring the concept of the automation through this sheet for different tasks. Now we'll see the next slide. In this slide, if you see, I pull the report from the web, the advantages of the DevOps implementation, the benefits of DevOps practices and implementation as per the industry reports. And if you see, this is the thing we have discussed it through the DevOps practices. And 21% they are getting reduction in time spent fixing and maintaining applications. So it means earlier 100% if they were working on fixing and maintaining, that is reduced to 20%. It means 80% time is saved it, and improvement in application quality and performance. Obviously, when you don't have bug fixes, when you don't have starting weekday, Monday, Tuesday incidents in production, your time is saved it, and obviously 81% is saved here, and 18% increase in revenue. Obviously, this is going to be a $1 million question: how much percentage is going to be increased in my profitability? Business owners might ask it by implementing DevOps practices. This is one of the best example. And 33% increase in time for infrastructure improvements, like whatever practices we have planned it in DevOps practices for infrastructure management, those all are implemented it in DevOps practices. With that, 30% increase is happening it in time for infrastructure improvements. So that is saved a lot for infrastructure setup and cost also. And 15% increase in time for self improvement, because of the collaboration team is happening it, innovative things are being identified it through those things, knowledge sharing is happening it, and 60% increase in application release time. So number of builds are increased it, and under CDI, continuous delivery, deployments are happening it, and DevOps practices are going to be helpful to development and operations teams up to operate activity. So if you see the loop, DevOps loop: plan, code, build, test, release, deploy, operate is happening, and on top of these things there is a continuous feedback loop is there that is working on that. So that's all. These are the industry reports demonstrate from the IT sector, and with this organization can get benefits. Now we'll see the 2016 report also from the web. I have pulled it. What it states: year-on-year growth for DevOps is 3%, and DevOps practices team size in 2016 is increased. Only DevOps team within the IT strength is 22%, and if you see here, DevOps team increased from year on year. If you see 2014, 15, 16, 3% we have seen here from this report. And if you see overall, high performing IT organizations report experiencing 200 times faster, more frequent deployments are happening comparatively with the earlier stages in the traditional method, and 24 times faster recovery from failures are happening, and 3 times lower change failure rate. It means failure rate is decreased it, obviously, because of the short cycles, short requirements, and short lead times are helping them. At the same time, high performers are being produced it through the DevOps culture, and unplanned work and rework is reduced to 22%. When you have such kind of things, obviously that is the best example for the team's happiness without having 11th or tasks before leaving from office to home. That is the advantage. So with this one can understand to start their management practices change into DevOps culture. We'll see in the next slide. In the next